Hello, I'm Tamara Galloway from London, England, and I'm going to talk to you about audio basics. The first topic is propagation, or how a wave, for example a sound wave, moves through a substance, for example air. The crucial point here is that only the sound wave moves through the air itself doesn't move. First of all, the air molecules are forced together into a smaller space than they'd normally occupy. Then they're forced apart into a larger space than they'd normally occupy. Then they're compressed again, then rarefied again. And you end up with bands of compressed air followed by rarefied air, like this. As the speaker moves out, it compresses the air. Then as it moves back in again, it rarefies the air. The second topic is amplitude. This is the distance from their normal position of the air molecules, or if you plot them out, their distance from the centre line. This can be their distance above the centre line in a positive direction, or their distance below the centre line in a negative direction. The maximum amplitude is known as the peak amplitude value, or simply the peak value. It corresponds roughly to the loudness our ears hear, but not exactly. Our ears are much more sensitive to sounds at particular frequencies, for example between 3000 Hz or 3 kHz and 4000 Hz or 4 kHz. And we can find out exactly how loud our ear perceives a particular sound as using a Fletcher-Munson equal loudness contour curve, like this. It has the frequency in Hertz along the horizontal axis and the sound pressure level in decibels along the vertical axis. For example, at 40 dB SPL, you can see that at only 100 Hz frequency, in other words at a very low frequency, our ear perceives that as only being at 0 phons, spelt PHONS, whereas if we have that same 40 dB SPL at 3000 Hz, our ear perceives that as 40 phons, which is a great difference. And you can find out exactly how many phons our ear will perceive a sound as being at by looking along the horizontal axis at the frequency in Hertz and then going up to the dB SPL and seeing which phons curve your finger lands on. The next topic is frequency. This is the rate at which a sound wave repeats one complete cycle of positive and negative. A high frequency sound will have several cycles in a short space of time, or several curves if you plot them out, whereas a low frequency sound will have only a few much gentler cycles or gentler curves in that same time. I've plotted out the high frequency sound in green at the top and the low frequency sound in red along the bottom. The final topic is timbre. What allows our ears to distinguish sounds with the same pitch and loudness, or everything else which isn't pitch and loudness. Timbre is determined by 4 main factors. First of all, by the upper harmonics of a sound, their number, where exactly they are, and their intensity, how loud they are. Secondly, it's determined by the attack-decay envelope of the sound, especially how the sound begins, but also how it ends. Thirdly, timbre is determined by changes in the fundamental, known as vibrato, and changes in the harmonics. And finally, it's determined by the range between tonal or pitched sound and noise-like or random sound. I find these audio basics really fascinating, and I hope you have too.